In this lesson, we will first learn deleted neighborhood point. So what is a deleted neighborhood point? Well, I'm going to draw a plot to demonstrate it. So as we learned before in the last lesson, we learned about local area. It's the area that is formed by the solution of x to an inequality. So let's just take this point 5 as an example. So the local area in this case will be formed as negative epsilon plus 5, and this here is positive epsilon plus 5, and you can write this as 5 minus epsilon and also 5 plus epsilon. So what is the local area of this? The local area of this is this. This is the local area of the inequality that satisfies the inequality, the values that satisfy the inequality. So how do we, this is the local area, but how do we represent the area that does not include the 0.5? So that does not include the 0.5. So everything in the local area except for like we want to remove 5. Well, in that case, you want to go ahead and draw the area like this. These two areas do not include 5. The 0.5 is excluded. How do we write this? Well, we can write it like this. 5 minus epsilon, so that's this point, that's this place here. And then 5 union, so like combined, 5 all the way to here, you see, 5 plus epsilon. Now, here's something to know. This round bracket means open brackets. This is an open bracket. Now, in an open bracket, the border values are not included. The border values. So the border values in this case, like 5 minus epsilon and 5 plus epsilon. Those are the border values. And the open brackets do not include the border values. However, a closed bracket, like the square bracket, this does include the border values. But we're looking at an open bracket in this case. So this deleted neighborhood consists of two parts. So it consists of two parts with open brackets. And to speak it more clearly or in like a general form, the deleted neighborhood is the local area of A that deletes the point at A. So in this case, the deleted point here is 5. Now you might be asking, hey, if this is an open bracket, then doesn't that mean that 5 minus epsilon is also deleted and that 5 plus epsilon is also deleted? Well, remember, epsilon is variable, right? You can get epsilon to be any value such that it meets the local area that you want, right? However, 5 is a fixed value. So no matter what epsilon is, 5 is going to be deleted, but epsilon can be given any value such that you can get the local area that you want, right? So, in this case, we're still looking at a deleted neighborhood. Having understood deleted neighborhoods, we will now study the accumulation point. What is an accumulation point? The accumulation point can be defined as if A, for example, is an accumulation point, then this means that any local area of A contains an infinite number of points. To demonstrate it, we're going to draw this plot and put A here in the middle. A here. So the local area of A, what can it be? Well, it can be this area, right? It can also be this area. It can also be this area, of course, depending on what epsilon is. So now here's the thing. No matter how narrow the local area is or how small epsilon is actually, so remember, this is, for example, this can be epsilon. The local area contains an infinite number of values, meaning that there are an infinite number of values of x that satisfies the inequality. So, for example, let's say that epsilon is equal to 0.01. This is a very small value. Let's say that a is equal to 8. Well, we're solving this inequality. We're solving x minus 8 is smaller than 0.01. You get that You got 8 minus 0.01 and also 8 plus 0.01. So now how can we explain that there are an infinite number of points in the local value? X can be, let's see what X can be. X can be 8.0001. X can also be 8.0002. X can also be 8.0003, and so on. And there are an infinite number of x values, which you can actually you can come up with an x value. There are an infinite many to satisfy this inequality, and therefore the local area contains an infinite number of values. So in calculus, the accumulation point is also called the limit point. It's also called the limit point.